Good morning, everybody. Now we've merged into one super duper TV channel, and so we bounce back and forth between the two channels. I'm normally on TV doing the weather on the NBC channel at 4 o'clock in the afternoon, and then I move next door at 6, 7, and 11 for the late night shows on the ABC channel. So during those important hurricane advisory updates, like at 11 p.m., if you're bouncing around the channels, you want to stop at ABC, that's totally cool. Been here for about 11 years now, and I've done quite a few hurricane seminars here at Verona Walk. So if you've been to one of my seminars before, don't spoil any of the answers. But what I strive to do with all my hurricane seminars is teach you something that you didn't know before. If you need to know that you need to have bottled water on hand, you probably don't need to be here. So what I wanted to do instead is talk about some of the specific things that make Collier County so vulnerable to hurricanes, and most especially the concept of storm surge. I know here in Verona Walk we don't have a Gulf front property, but we are in a storm surge zone here, and that means that there are scenarios that actually show saltwater storm surge making it as far inland as where we are here in Verona Walk. Anybody who lives in an evacuation zone is at some point under the threat of storm surge. So even though where you folks are in Zone D is not the highest concern, the biggest worry you have, just have in mind that should we get hit by a really big monster of a storm, there are scenarios that show saltwater, in some cases making it as far inland as where we happen to be. So let's first talk about what an average hurricane season is. So in the Atlantic Basin, which refers to anything that pops up in the Atlantic Ocean, the Gulf, or the Caribbean, we typically see 14 tropical storms, 7 hurricanes, and 3 major hurricanes. The term major hurricane simply refers to any hurricane that becomes at least a Category 3 or stronger. Doesn't matter if it's in the middle of the ocean or making landfall. A major hurricane is any storm that becomes at least a Category 3. Oftentimes there's a lot of folks from the Northeast who live down here and they say, well, Sandy was definitely a major hurricane, right? Technically for the record books, when it was making landfall, it was well weaker than a Category 3 storm. So for the record books and for record keeping, anytime you hear the phrase major hurricane, it is simply referring to a storm that's at least a Category 3 or stronger. And when you have Category 3s or stronger, the impacts are oftentimes much greater on land. As you know from living in Florida, you've probably heard of the Saffir-Simpson scale. This is a wind scale, a wind intensity scale that gives you a broad idea as to what kind of wind damage one could expect if you're hit by these hurricanes. And what they do is they group them into ranges of those wind speeds. So obviously, as you can see on the screen here, these animations were created by the National Hurricane Center to give people a broad idea as to what kind of wind damage one could expect to see during these types of storms. So a Category 1 hurricane refers to a hurricane where the National Hurricane Center can find evidence of sustained winds between at least 74 and 95 miles per hour. The phrase sustained wind refers to the average wind speed over a 2-minute period of time, so like the constant wind speed that an area would experience. And you can see here as we go through the little pictures how the amount of wind damage increases quite substantially as we go up above Category 3s and Category 4s. Now, I also need to remind you that you live in a really nice area here in Verona Walk, and your homes and our homes in South Florida have higher building standards than other parts of the country. So I know this shows, homes being pushed off of their foundations in a Category 5, but in a community like yours here in Verona Walk, remember that your buildings are relatively new and they're built really, really strong. So we would see lesser wind damage in an area like Verona Walk that is built so well. But what is most important to take away from the Saffir-Simpson scale is that it is only accounting for the wind. It's telling you nothing about the amount of inland flooding that could happen from rain. It's telling you nothing about the amount of storm surge that can happen near the Gulf. It's telling you nothing about how long or how fast the hurricane is going to impact your area. It's only taking a snapshot of one piece of information based on how fast the strongest winds are. And that's super, super important. A lot of people, especially in Florida, say, well, if it's just a Category 2, I'm not even going to get canned tuna or whatever like that. You're not going to take it seriously until it's at least a Category 3 storm. And something I'd like to convey to you today is to make sure you tell your neighbors not to do that, because even Category 1s and Category 2s and even tropical storms can be really, really impactful events depending on what sort of impacts they bring, like rain and how fast the systems are moving. So obviously one of the biggest impacts that we've seen in our community so much in the past couple of hurricane seasons is this concept of storm surge. And storm surge, the easiest way to think of it is saltwater flooding. It is water that is normally in the Gulf or in the Atlantic Ocean that is pushed from those bodies of water onto shore. Could I possibly have 2 volunteers? All you got to do is stand up here and hold a piece of paper, nothing more. Okay, how does that have John? What's your name? Cheryl. And Cheryl. All right, pretend that John and Cheryl are holding the Atlantic or holding the Gulf. What to picture with storm surge? How do you visualize what storm surge is? It's not a single wave, it's not a tsunami, but instead the way to picture what storm surge looks like is a dome of water that is moving underneath the hurricane. So John and Cheryl are holding what the surface of the water looks like on just your regular sunny day. But if we had a hurricane form here, you guys keep holding where you are, imagine the water underneath the hurricane rising like a big dome. And that dome of water follows wherever the hurricane happens to move. So if the hurricane is moving toward John, notice how this dome of water is following John. That's what storm surge is. It's not a one-time wave. Instead, it's like this big rise of water. Most of it, 95% of that dome of water, is caused by the intense winds around a hurricane. A smaller percentage, about 5% of that water dome, is caused by the vertical uprising of air inside the area of low pressure inside the hurricane. Either way, though, the way to visualize or picture what storm surge looks like is a dome of water that is underneath the hurricane that follows it, and wherever that hurricane makes landfall, that dome of water gets pushed on shore, and that's what causes the saltwater storm surge that we've seen so much of in the past couple of years. Thank you much. You can take a seat. This is an example of some storm surge damage. It's also really important to stress the idea of how we measure storm surge. So what I wanted to do here, could I have someone else help me out, or one of you two as well? I do a lot of presentations at school, so your kids get a kick out of this stuff. What's your name? Sue. Okay, Sue is good. Every time we talk about a hurricane going forward and you hear the word storm surge, picture Sue, because Sue is going to show you how to visualize and demonstrate what storm surge looks like. The National Hurricane Center always expresses storm surge inundation or storm surge flooding as being from ground level in whatever location they're talking about. So if we have storm surge inside this conference room, you should imagine it being from the floor upward. So this is what 3 feet. A few years ago, we had a hurricane called Hurricane Elsa that brought about 3 feet of storm surge flooding to the Fort Myers area. So Sue, if you would, hold that stick right there. So 3 feet of storm surge flooding comes about to Sue's waist. A few years before that, in 2004, we had a hurricane called Hurricane Charlie that made landfall in basically northern Lee County and western Charlotte County. Had winds of 150 miles per hour. It was as strong as Hurricane Ian was, and it caused about 6 feet of storm surge flooding. That means 6 feet from ground level in the area that the hurricane made landfall. That's already over Sue's head. It's just about to the top of my head. And then here is what 9 feet, well, not hit the fan, but this is what 9 feet of saltwater storm surge flooding looks like. 9 feet from the bottom of the ground all the way up. In some of the hardest hit areas of Fort Myers Beach during Hurricane Ian, there was evidence of storm surge going upwards of 15 feet. That's one person holds a measuring tape at the ground, the other person takes that measuring tape to where they see the high water line, so where you see the dirt and debris. So up about 15 feet is where some of the worst of storm surge was during Hurricane Ian. So going forward, whenever you hear storm surge spoken about on TV, picture Sue and picture these posts. And from ground level, that's what our National Hurricane Center is trying to communicate as to how deep that saltwater flooding happens to be. Thank you very much. You can have a seat. Now the picture you see on the screen is evidence of storm surge flooding. Looks like a bulldozer went through. Looks like the kind of storm surge that Hurricane Ian caused on Fort Myers Beach. Let's do a quick little game here. Tell me what kind of hurricane on the Saffir-Simpson scale, what category hurricane caused that kind of storm surge damage? Raise your hand if you think it was a category 1. Raise your hand if you think it was a category 2. Raise your hand if you think it was a category 3. Raise your hand if you think it's a category 4. And raise your hand if you think it was a category 5. Hold on to your seats. That was caused by a category 2 hurricane. It was Hurricane Ike. Hit the coast of Texas, if I'm not mistaken, in 2008. And even though Hurricane Ike was only a category 2 hurricane at the time, it caused upwards of 12 feet of saltwater flooding on the coast of Texas. That should blow you away because Category 2 hurricane, your neighbors ought to be getting bottled water for that kind, right? So what I want to express here today is why could something like a Category 2 hurricane cause so much more storm surge than sometimes even bigger hurricanes? So let's continue on here. Let's do a few storm surge comparisons. The first storm I'd like to compare will be Hurricane Ike that we just saw the photo of from 2008 and Hurricane Charley in 2004. Hurricane Charley hit our area, again, northern Charlotte County, northern Lee County, with right over top of Punta Gorda with sustained winds, the constant wind speed of around 150 miles per hour. That was as strong as what Hurricane Ian was. But Hurricane Ike and Hurricane Charley, Ike was a 2, Charley was a 4. Why would Hurricane Ike, the Category 2 hurricane, cause so much more storm surge than Hurricane Charley? Well, one of the big reasons was how wide the hurricanes were. So next time you watch hurricane coverage, keep an ear to when the meteorologist talks about the width of the storm. On the left-hand side of your screen, you can see a satellite image of what Hurricane Katrina looked like. That was the one that laid waste to the New Orleans area. The max storm surge flooding was 28 feet above ground level in parts of Mississippi and Louisiana. That's 28 feet from the grass upwards. So there was like bathtubs on tops of houses because of how bad the flooding was there. But from one side to the other, Hurricane Katrina was about 400 miles wide. That's really, really wide. Now, look at the satellite image on the right. That's a satellite image of what Hurricane Charley looked like in 2004. Charley was actually stronger at that point in time than Hurricane Katrina was, but look at how much physically smaller Charley was. From one side to the other, it was only 150 miles across. And inside that 150 miles, the extent of hurricane force winds was only about 15 miles from the center. So if you were 30 miles away from the center of Hurricane Charley, you weren't even experiencing hurricane force winds. This plays a giant role in how much storm surge is going to happen. Think about your grandkids in your pool. If I was in your pool, I have these big lanky arms. I could move around a whole lot more water than your grandchildren who have smaller arms. They don't have as much arms to push water around. I do. The wider a hurricane is, the more water it can push. So not only is more of the coastline impacted when a storm is really wide, but also the depth of the storm surge can be substantially deeper as compared to a hurricane that is physically more compact. So during hurricane season, when you're listening for the Saffir-Simpson scale number and all that kind of business, also keep an ear to how wide, how far do hurricane and tropical storm force winds extend, because that plays a big role in how bad the impacts may potentially be. If you've already seen these images before, I apologize, but this is some of the most compelling images I've ever seen about the intensity and the speed that storm surge moves. This is what Fort Myers Beach, think back to the day that Hurricane Ian made landfall, and this is what Fort Myers Beach looked at 10:38. What this guy did is he attached some sort of really strong camera on one of those concrete utility poles that was on the beach. So that tall building on the left is the Lani Kai Resort. Your kids probably having some fun at one point or another. And then that's Estero Boulevard there in the middle. That's what things look like at 10:38 in the morning. This is what they looked like by 3:03. So in a span of from 10:30 to 3 o'clock in the afternoon, the salt water had risen, in this case, probably up to about 15 feet because the hurricane made landfall during the 3 o'clock hour. So this is 3 o'clock in the afternoon, and that's 5 o'clock. Look at that, in the span of 2 hours, all the water was gone. But notice the kind of structural damage. I mean, there's buildings that weren't there anymore, you know, from 10:30 in the morning from when the photographs start. So the storm surge moves fast, and if you're stuck in an area where storm surge is moving, what you need to express to your neighbors who might live closer to the beaches if they don't want to evacuate is that idea of vertical evacuation, going higher and higher into your house, because there's not really anything you can do to escape storm surge when the storm has already started because of how fast and how deep the water can get in a very, very short period of time. Now let's do a comparison of Hurricane Irma from 2017 and Ian from 2022. By show of hands, was everyone here during Hurricane Irma in 2017? So if you weren't here, Irma was the big one before the big one. We thought that Irma was the worst that could throw in our area, but we were obviously very mistaken once Hurricane Ian finally made landfall in 2022. A lot of people made their decisions on what they were going to do during Hurricane Ian because of what happened in Hurricane Irma. And that's a really big mistake. No two hurricanes will ever be the same. Even if they're the same number on the Saffir-Simpson scale, their impacts are never going to be the same. Oh, yeah,
the comparison I heard with Irma was that if the back eyewall didn't fall out like it did, it would have been like what Ian's storm surge was.
Wow, I should pay you like $5. So that's my next graphic. What your neighbor mentioned here is this graphic I'm going to pass around. What you're going to see here is on the the left-hand side is the storm surge that Hurricane Irma caused, and areas in red show you upwards of 9 feet of saltwater flooding. On this side shows you if Hurricane Irma had not made landfall over Marco Island, how much worse the storm surge would have been. And when you look at the inundation flooding, notice how it looks remarkably similar to the storm surge that actually occurred during Hurricane Ian. Had Hurricane Irma not made landfall over Collier County, we would have had way more storm surge and way more wind damage than it did had it stayed over the open waters of the Gulf. Because once a hurricane makes landfall, you take away its biggest fuel source, warm, open water. So as soon as the hurricane hits land, it starts to weaken. So if Hurricane Irma had stayed 20 miles offshore, it would have still been over top of warm water and more areas would have been exposed to storm surge. So I'm going to pass this around so you can take a closer look at it. But like your neighbor mentioned, we got lucky, in fact, that Hurricane Irma actually made landfall, because if it didn't, we would have had like a Hurricane Ian before Hurricane Ian. Can you pass that around there? Thank you for bringing that up.
No problem.
Let's show some visuals here to kind of illustrate that concept of why it's so important on where storms make landfall. On the left, that red circle shows you where Hurricane Irma made landfall on Marco Island. On the right, that red circle shows you where Hurricane Ian made on a little place called Cayo Costa. Those two locations are not very far apart, but that made a gigantic difference in where the worst storm surge ended up. Think about how air spins around a hurricane. Whenever a hurricane gets close to shore, somebody's going to see onshore wind, where the air is coming from the water and pushing toward land, and somebody's going to see offshore wind. That means air that's coming from the land, pushing toward the water. Because of where Hurricane Irma made landfall, where it did on Marco Island, where were all the onshore winds? Well, they were aimed at like the 10,000 islands in areas east of Marco Island. That is loaded with mangroves, the world's best storm surge protection. Those mangroves have a great way of reducing the intensity of inland push of storm surge. On the other hand, Hurricane Ian made landfall, less than 60 miles away, but because it made landfall where it did, look at all that open coastline of Lee and Collier that was then susceptible to the storm surge flooding. So during Hurricane Irma, yes, we had more than 9 feet of storm surge, but the worst of it was areas east of Marco Island because of where the storm made landfall. In the case of Hurricane Ian, storm made landfall a bit farther north on the coast. It means all of the southern parts of Lee County and all of western Collier County was exposed to the storm surge. Unfortunately, it is really difficult beyond more than like 24 hours to get a solid idea on exactly where a storm is going to make landfall. And that's why emergency managers need to evacuate people who sometimes are unnecessarily evacuated. Because if Hurricane Irma had stayed where it was expected to go, again, we would have had the same kind of event that we had during Hurricane Ian just a few years later. So to quickly review our 2 points here, how wide a storm is really important. The wider it is, the more impacts we see, especially from hurricane storm surge. That 400-mile figure, that seems to be about the key figure. When you hear about hurricanes that are about 400 miles wide, that's ones like Ian, Irma, and Katrina. Those are the ones that have the really big width that cause more intense storm surge. The more narrow a hurricane is, the lesser the impacts of storm surge outside of areas that are outside of the hurricane force winds. Where a hurricane, of course, makes a really, really big difference. If it's hurricane, in our case, if it makes landfall like where Hurricane Ian was, or just like a Bonita Springs area, if the center of a hurricane ever makes landfall in areas like Bonita Springs, it's this part of Collier County's coastline from Bonita Springs southward where the most intense storm surge is going to be. If a hurricane makes landfall east of you, like east of Everglades City, the storm surge will be on east of Everglades City, and the water levels in western Collier would actually fall. The water levels would get lower off the Naples and Benita Springs area because the water is being pushed offshore. So pay very close attention to where the center of the storm is most likely to go. And that's what you should be using those hurricane center forecast cones for. You know, where they show you where the center of the storm is now, and that gigantic cone that extends from where the hurricane is. The only thing the hurricane center is trying to convey with you with those cones is where the center of the hurricane is most likely to be. Now, probability-wise, obviously the center of the cone is where it's most likely to be, but anywhere inside that cone is fair game for that hurricane to be at that point in time. Those cones are updated every few hours for a reason, so it's important to make sure you stay up on the latest revised forecast cone that are released at 11 a.m. and 5 p.m. and then 5 a.m. and 11 p.m. Those are really important times to make sure you're near a TV or near your phone should we be watching another hurricane move our way. How fast a hurricane moves is also a big deal. Think about a Band-Aid. Hurts a lot less if you rip it off really fast as compared to taking your time and slowly peeling that Band-Aid off. Hurricanes work the same way. The slower they move, the worse it's going to be. The faster they move, the easier it's going to be. The great comparison is between Hurricane Charlie and Hurricane Ian. At our latitude, the average forward speed of a hurricane, like how fast the whole system is moving forward, is between 12 and 15 miles per hour. So when you're watching the news, and if I say the hurricane is moving less than 12 miles per hour, that should raise some red flags because it means it's moving relatively slowly. Hurricane Charlie, that was the category 4, as strong as Hurricane Ian, but only produced 6 feet of storm surge. It was moving forward at more than 15, 16, 17, 18 miles per hour. The forward speed was very, very fast, unlike Hurricane Ian, which was moving less than 5 miles per hour. So the slower a hurricane moves, the more time it has to collect and push water towards shore. So if we have to get hit by another hurricane again, we want it to move as fast as possible. And at our latitude, the best case scenario is if it's moving forward faster than 15 miles per hour. So remember those numbers because they're really important. Less than 12 miles per hour, we're going to have more headaches. Faster than 15 miles per hour, it's going to be a little bit of an easier event for us across the board. The next thing to pay attention to is something we have no control over, and it is the shape of the coastline. Not only the shape of the beaches, but what the shape of the earth looks like underneath the surface of the water. And this is one of the most fascinating things to me, that how big of a role this plays in storm surge, but how very few people in our community actually know about what the shape of the earth looks like underneath the Gulf. Let me show you. So the map on your screen, and I've printed out another one on a piece of paper that we're going to float around the room so you can take a closer look at it. This map is called a bathymetry map, and what it's looking at is the shape and the structure of the earth underneath the surface of the water. On this map, deep, deep purple is very, very deep water. Red, yellow, and orange, those are relatively shallow bodies of water. There is a huge difference off the coast of Collier as compared to, say, off the coast of Broward County, isn't there? Anyone ever go deep sea fishing before? Well, off the coast of Naples, you have to go really, really far out to sea over the Gulf to get to deep water. If you go deep sea fishing off of Fort Lauderdale or Hollywood, you don't have to go nearly as far. That's because the water gets super, super deep, super, super fast off the coast of Broward County, but off of our coastline, there's a very slow and gradual drop down to the deepest point in the Gulf. So I'm going to pass this piece of paper around so you can take a closer look at it, because this is really fascinating and is a gigantic reason why our area is so much more vulnerable to storm surge as compared to parts of the East Coast. I mentioned before how your kids and your grandkids love the posters, so I thought we could do this both ways. Could I have someone hold this poster for me? Oh, thanks, buddy. What's your name? Tony. Okay, very good thing, Tony. All right, so what Tony has here is a cross-section of Florida. You remember cross-sections from elementary school and middle school? So we've taken Florida and we've kind of cut it in half. And that's what the coastline of Florida looks like if we were to take a cross-section of the Gulf, and this is what a cross-section of the east coast of Florida looks like. If you can't see the poster, look on the screen here. On the left-hand side, that's a cross-section of what the west coast of Florida looks like. The other side is a cross-section of what the east coast of Florida looks like. Notice how once you get off the coast on the east coast, the water gets super, super deep. Off of our coast, it takes a while for you to find really deep water. So on just your regular day at the beach, the water, if we were to put the water back in the Gulf, the water level would look like that. And if we put the water back in the Atlantic, the water would look like that. And I'll put it up on the screen too. So, how does this continental shelf, the shape of the Earth underneath the surface of the water, impact storm surge? Well, you can see it on the screen here, and you can see it on the poster. On the East Coast, if there's a hurricane moving from the Atlantic toward, like, say, Fort Lauderdale, they'll certainly have storm surge on that side of they'll certainly have storm surge on that side of the Atlantic Ocean. But notice the difference in the depth and the inland extent of how the water can move on our side of Florida as compared to the Atlantic side. That deep and steep continental shelf offers areas like Broward County a natural form of storm surge protection that we can't see because it happens underneath the ocean. Unlike on our coast, where there's no deep and steep continental shelf, there's nothing underneath the surface of the water to hold it back when a hurricane is moving toward shore. That's why the storm surge can go so far inland and be so much more deeper on our side of Florida as compared to the east coast of Florida. All right, thank you, Tony. You can have a seat now. If you want to take a picture of the screen and go down a rabbit hole, that is the most interesting website perhaps on the entire internet if you're thinking about storm surge. It shows you something called the SLOSH model. This has been designed by the National Hurricane Center over a number of years to better convey to the public how bad storm surge can be across every coastal area of the United States that is potentially impacted by hurricanes. What they've done is they've run hundreds of thousands of simulations and taken into account what past hurricanes have done, and they've offered us these simulations showing not only how far inland the water can go during various hurricanes, but also how deep it can be. Emergency managers then take that information and they draw the evacuation zones by county for every county in Florida. So as I mentioned when we started things off, if you live in an evacuation zone, there's scenarios that show saltwater flooding making it as far inland as you are. Now, the zone that you're in, based on the letter, shows you how high of a risk the zone happens to be. So here in Zone D, obviously the risk of storm surge is significantly lower than in Zone A. But if you live in an evacuation zone, there's still the opportunity that water could, in some scenarios, make it as far inland as where we live. So this is a look at evacuation zones across Lee County. I know we're not in Lee County, but something I just wanted to point out here, I'm actually looking at this as a segment. There's more than 300,000 people that live just in evacuation zones A and B. That's a lot of cars and a lot of minivans jumping on the interstate at the same time if a hurricane happens to call those two evacuation zones. Which is why I want to stress again that if you're going to evacuate, it's better to do it proactively and on time and not dilly-daddle, because if you do it, there's 300,000 other people in Lee County that are going to be doing the same thing. Here's the evacuation zones for our community here in Collier County. And Collier, if I'm not mistaken, is one of the, besides Monroe County, is one of the only places in Florida where nearly every single person who lives in the county is in an evacuation zone. And that also includes areas as far inland as Ave Maria and Immokalee. Now, clearly, if we get water from the Gulf to go as far inland as Immokalee, we've got a really, really bad situation on our hands. But it's important. They don't draw these maps for fun. They draw them for a reason. There's enough evidence based on just how bad a storm could potentially be that there are scenarios that show water that far inland. Now remember, it's going to take a gigantic hurricane and one that's not moving at all to send water that far inland. So the chance of something like that ever happening is very low, but unfortunately it's not zero. And as we have learned as a community together, we can't just brush something off because there's a low chance of it happening. Who would have thought that we would have had Hurricane Ian and then just a few years ago had Hurricane Debbie, Helene, and Milton and all in quick succession? I mean, Hurricane Milton's storm surge was as bad as Hurricane Ian's was, just a little bit farther up the coastline. So, you know, I'm not showing this is scary. I just want you to make sure that, you know, you're not alone in your evacuation zone. And everybody who lives in Collier County is in an evacuation zone. So you just have to keep these kind of things in mind. The other thing I want people to know is that don't assume that every county in Florida is set up the same way we are. As you now know, the evacuation potential is much higher in our area because the storm surge risk is higher. So this map here shows you what the evacuation zones are for all of the communities in South Florida. Look at in Broward County. Holy smokes, nobody who lives to the west of US 1 is in an evacuation zone. Unlike in Charlotte, Lee, and Collier, where nearly all of the populated areas are in evacuation zones. I oftentimes get the question, why is the northern part of Collier County in the evacuation zone while that little corner of Lee County isn't? So the hurricane evacuation managers and storm surge, they take a look at how far inland. So when you look at the storm surge maps on that website that I showed you, you'll see that in the worst of the worst possible scenarios, the water does go up to about where Immokalee is. But in that part of Lee County, there's no towns or people or anything. So Collier County kind of they kind of rounded the edges out a little bit more. But where those evacuations go mimics where you look at that website from the National Hurricane Center, that slosh model, that's about where the farthest inland extent of the water is. So I show this to you because, again, if we have a big hurricane coming our way, don't go north, thank you, don't go north on I-75. Because like we talked about a second ago, there's going to be 25 million minivans in Cape Coral and Fort Myers all going in the same direction. In our area, especially where you folks are in Zone D, you should kind of be the evacuation point. Your neighbors in A and B should come to your house in Verona to ride out the next one, as long as we have one, obviously, where evacuations aren't necessary this far inland. A lot of people's instinct is, I've got to get to Cleveland, or Chicago, or Canada, or as far as I possibly can get away from this hurricane. And as many people learned during Hurricanes Irma and Ian, that is a disaster after a disaster, because not only how bad the traffic gets, but because of the compounding effects of not being able to find a hotel room, running out of gas, having fender benders, and all these things that people learned as they were trying to come back from Atlanta, coming back from Cleveland, or wherever they happened to evacuate from. So local evacuation within our area is the best way to think about evacuation zones. And you guys made a good decision living in Zone D, because it's going to take a whopper of a storm for evacuation Zone D to be called. So if you have friends or family in zones A or B, make a plan right now to have them come stay with you instead of them driving to Canada or wherever they want to go during the next big hurricane. The next thing I wanted to talk a bit about is the seasonable forecast. As you've heard, I'm sure, the expectation is that this year will probably be an average or above average season. Not quite as bad as last year in terms of the number of storms, but still a fairly active season. There's a number of things that go into those forecasts, like what the water temperatures are doing in the Gulf and the Caribbean and the ocean and all those kind of things. But a really big one is something called La Nina and El Nino. Has everyone heard of these two words before? Yeah. Raise your hand. Do you know what they mean? Raise your hand. Okay. Well, nobody does. I oftentimes get frustrated when I watch the news on TV where they just rattle off the words El Nino and La Nina like as if everybody knows exactly what they mean. So what I wanted to do here for a second is, one, talk about what they mean, and then kind of explain to you how they can impact hurricane season here in the Atlantic. Because La Nina and El Nino are not storm systems, they're not weather fronts, and they don't even happen anywhere close to Florida. What we're talking about when we reference the words La Nina and El Nino would be what the water temperatures are doing off the coast of South America, along the equator in the Pacific Ocean are doing. Isn't that wild? When you study the weather, you'll see just how interconnected the world really is. And even though the Pacific Ocean is an awfully long ways away from where we are here in South Florida, it plays a really big role in our weather, not only during hurricane season, but during the winter time as well. So the most basic definition of what the El Nino is when the Pacific Ocean off the coast of South America along the equator is running warmer than average, anywhere from 3 to 5 degrees Celsius warmer than average. I know that doesn't sound like a lot, but when you think of just how big the Pacific Ocean is, that's a lot of warm water, meaning it's a lot of energy, a lot of heat out there. And it typically means in the wintertime that we see more severe weather here in Florida. But La Nina is the opposite. It's when the El Nino comes to an end, and then the water temperatures along the Pacific Ocean off the coast of South America end up cooler than average, on the order of, say, 3 to 5 degrees Celsius. And I know that doesn't sound like a lot, but when you think about just how much water that is, that's a really big deal. It has a really big cascading impact. Can I have one more person help me out? All you've got to do is hold up this great poster board. Thank you. What's your name?
Angelo.
Angelo. Okay, Angelo, if you will. Thank you. If you would, hold this poster here. Right. So we're back in elementary school. Pacific Ocean. North America is right here. South America is here. And the Atlantic Ocean is over here. Okay, let's talk about how this all connects to hurricane season. So let's assume that we're in an El Nino. That's when the water temperatures in the Pacific are relatively warm. So what you see when you look at a water temperature map, is off the coast of South America, you see lots and lots and lots of warm water that extends off the west coast of South America. Everyone sees that? So you see a giant strip of warm water off the coast of South America. You know that when the water temperatures get warm, you typically see a lot of tropical storms and hurricanes. So during El Nino years, we have lots and lots of activity happening off the west coast of South America. What then happens is that energy, that rising air, is translated into some of the upper air currents that move the other direction. So during years when we have lots of hurricanes in the Pacific Ocean, we end up with a lot of upper level winds known as wind shear that start moving toward the Atlantic. If you watch a weather report for more than 5 minutes during a hurricane season, you've probably heard somebody talk about wind shear before. That's where the winds are moving stronger or in a different direction the higher up in the atmosphere you go. If you're from the Midwest or the Northeast, you probably remember the weatherman talking about how wind shear can create tornadoes. Down here, it's the exact opposite. Hurricanes hate wind shear, rips them apart, because what a hurricane wants to do is organize vertically and be really, really tall. Wind shear is when there's stronger winds in the upper parts of the storm. So the storm tilts over like this, and it makes it really tough for it to stay organized. So if we have lots of wind shear pushing toward the Atlantic Ocean, we end up with fewer hurricanes over the Atlantic. That means we want to cheer for El Nino during hurricane season, because it typically means that we see a lot fewer hurricanes than normal. On the other hand, the flip side is that La Nina thing. That's where we no longer have warm water temperatures in the Pacific Ocean, but instead end up with some cooler water temperatures in the Pacific Ocean. So on a water temperature map, you see lots of blues and purples on the water temperature map. That means there's not nearly as much rising air over the Pacific, which means less wind shear over the Atlantic. Those upper air currents end up going much, much farther north, aimed more toward the northern sections of North America. And then in exchange, with less wind shear, we get more hurricanes in the Atlantic Basin. So the super, super active hurricane years, more often than not, are going to happen during La Nina years. And the really, really quiet hurricane seasons are more often than not going to happen during El Nino years. Now, there's one more phase that's right in the middle. It's called neutral. That's where you're neither warmer or colder than average. You're right in the middle, and that's where we are right now. That means we don't have the benefits of an El Nino, but we don't have the downsides of a La Nina. And that's why we're likely going to see about an average hurricane season this year, because we don't have an El Nino and we don't have a La Nina. We're right in the middle, so the water temperatures in the Pacific are neither warmer or colder than what's considered average. Kind of get the idea? Okay, on the back, yeah. Thank you, buddy.
The only thing that's keeping us safe right now, from what I understand, is because we have a high pressure above the state pretty much.
Yeah, the other really, really great thing that we're not going to talk too much about today is something called the Saharan air layer. Have you ever heard of that? Man, that is so fascinating. So what that is it is literally pieces of dust, dirt, and sand from the Sahara deserts of Africa that is picked up and wafted into the atmosphere. The winds are so intense there that these little pieces of particulate matter are pushed from the Sahara Desert over top of the ocean, and they ride up in the upper parts of the atmosphere, around 20,000 feet or so. Inside these wedges of Saharan air, it's so highly concentrated sometimes that when you look at a satellite image, you can actually see brown and tan hues of sand moving across the ocean. At the same time, those little pieces of sand are absorbing the sun's energy, which means that layer of the atmosphere then starts to really warm up. That's like a kryptonite for a hurricane, because if a hurricane tries to form underneath or near the Saharan air layer, it runs into this dry and warm layer of air, and that just cuts the fuel right away from it. So even if you have super warm ocean temperatures like we do right now, at the moment there is Saharan air all over the Atlantic and the Caribbean, and by this weekend, some of it's actually going to make it into the Gulf. And that is great for us because it really helps to keep the hurricane season really, really quiet. There are some downsides. As you know, if it's a high enough concentration, if you have respiratory issues, sometimes you can have a problem there. And it actually has nutrients in it. So there could be a connection between algae blooms in the Gulf and big, big plumes of Saharan air. A long time ago, the Sahara Desert was in the desert. It was a lush green area. Everything died away, and the nutrients of what used to live in what is now the Sahara Desert are now in the sand and pieces of dust. So as that dust and sand gets picked up and pushed across the ocean, it acts like a big fertilizer. It actually is beneficial for the Amazon rainforest in South America, offers them things like phosphorus, but at the same time, when we have a lot of it moving over the Gulf, it drops a lot of that in the Gulf, and there could be a connection between algae blooms that we have in the Gulf and really, really high concentrations of Saharan air. So that's a great point. Okay, we're racing toward the end. I know you probably want to get up and stretch your legs, but I cannot leave without telling you about the benefits of the Gulf Coast News live Doppler radar. If you watch our newscast for more than 5 seconds, you're going to hear me or one of my coworkers say Gulf Coast News live Doppler radar. And boy, is it important that you know about this thing. Not only because it puts food on my table, but because it helps you stay really well informed, not only during hurricanes, but just during your everyday weather. In case you didn't know, we get lots of thunderstorms around here, especially in the summertime. So it's really important that when you're channel surfing in the afternoon, consider stopping by Gulf Coast News for a moment or two if it is storming in your house to get the best idea as to what that storm is doing. Why do I say Gulf Coast News live Doppler radar is the best? Well, not only because I work there, but because that is the closest Doppler radar to the city of Naples. The only other Doppler radars in our area are farther away, and that makes a big difference. Let me explain why. So, can I possibly have 3 volunteers to help me out? All you've got to do is stand up here, nothing more, I promise. Your grandkids love this kind of stuff. Come on, don't be shy. Okay? All right, thanks guys. Angelo, was it? Yeah. Okay, use your imaginations and pretend that Angelo just became a giant thunderstorm. So Angelo, if you would, let's have you stand right about here. So Angelo the thunderstorm is right there, and if you would hold that club there. And what's your name, sir? Richard is also a thunderstorm right here. So Richard the thunderstorm is going to stand over here. And what's your name, buddy? Michael. Michael is now the Gulf Coast News live Doppler radar. So the way I explain this to your kids and grandkids at school is I use a basketball. And I say, what would happen to this basketball if I threw it up against the wall? And your kids always say, oh, it's going to bounce back to you, right? Yeah. Now, if we went out into your lawn here and I threw the ball, does it bounce back?
No.
It does not. How come? Yeah, there's nothing for it to run into, so the ball just kind of floats off into space. Doppler radar towers do something very similar, but obviously instead of throwing basketballs out into the atmosphere, they're throwing pulses of energy out into the atmosphere. So what was your name?
Michael.
Michael, the Gulf Coast live radar, is going to hold the basketball here. So let's say, I don't know, it's 4 o'clock and you're watching Gulf Coast News, and I say there's thunderstorms over the Roanoke area. How do I know that? Well, we know that because Michael, the Gulf Coast live radar, is going to look this direction. And Michael, the Gulf Coast News live Doppler radar, sends out a pulse of energy into the atmosphere. And as soon as it runs into the raindrops or the hailstones or whatever happens to be inside Angelo the thunderstorm, it hits it and then it bounces back to the Gulf Coast News live Doppler radar. When you watch Gulf Coast News and you see those blobs of green and yellow and red or pink or black, whatever you see, what you're looking at is the energy that the radar tower is sending toward the raindrops that's hitting it and then bouncing back. So, if it's just light green, all the radar is picking up is just some light rain. If it's yellow or red, that means some really heavy rain. If it's purple or black, we're talking hailstones or maybe pieces of debris like roof tiles that are being picked up by something like a tornado. So the color that you see on the Gulf Coast News live Doppler radar can give you an idea as to what the intensity looks like when the showers and thunderstorms are pushing through. So this is awesome. Michael, the Gulf Coast News live radar, knows for sure there's definitely a thunderstorm right here because every time he sends that pulse of energy out, it bounces right back. Now, what is behind Michael, the Gulf Coast News live Doppler radar, that he can't see right now? What's over here? There's more storms, right? So what could Michael, Gulf Coast News live Doppler radar, do so he can see in all directions around him?
Rotate.
So start rotating, buddy. All right, so 24 hours a day. Every single day of the year. That's what Doppler radar towers do. They are constantly rotating and scanning the sky. So every time the radar looks this way, he sends out that pulse of energy. It runs into the raindrops or the hailstones or whatever is inside this thunderstorm. It hits it and then it bounces back. And when he rotates over here, he does the same thing. Sends out another pulse of energy, confirms that tornado or that thunderstorm is still there. Now, what is over here? Do we see any thunderstorms here?
No.
You don't. I don't. But more importantly, Michael, the Gulf Coast News live radar, doesn't see it either. That's because when Michael looks this way, he sends that pulse of energy out into the atmosphere and it goes higher and higher and higher and floats off into space. There's nothing for it to run into, so the energy beam shoots off into space. Kind of get the idea?
Yeah.
Okay, you guys can have a seat. Thank you very much. Thank you. I'll take that off. So why does it matter that you watch the Gulf Coast News live Doppler radar? Well, think of it this way. That's a map of what Central and South Florida looks like. Here in the United States, we are so lucky to have the National Weather Service, and we have radar coverage across most of the country. There's a few areas where we lack great coverage, but here in South Florida, we have pretty good coverage. That's because we are surrounded by National Weather Service offices in Tampa to our north, Miami to our east, and Key West to our south. Now, the Earth is not flat, which I unfortunately have to remind people in 2025 at some of these hurricane seminars, but the Earth is curved, and these energy particles from Doppler radar are sent out at an angle. That means the farther away you are from a radar tower, the higher in the storm the radar is going to be sampling it. Since I spend most of my day on the planet Earth, I would rather know what the radar closest to me is saying as compared to a radar that is very far away. Because the energy is shot at an angle, and because Earth is curved, the Doppler radar can see out pretty reliably for about 150, 200 miles or so. So from the National Weather Service office in Tampa, their best coverage is inside that yellow area. It goes to about the Fort Myers and Cape Coral area. Not so good when you're over in the Naples area. The National Weather Service in Miami is the closest one to us here in Naples, but still, that's a decent distance away. It's at the National Hurricane Center off of Tamiami Trail over in the Miami area. So we can see Naples way better than the Tampa radar can, but at the same time, that energy beam is relatively high in the sky. So why should you watch the Gulf Coast News live on the radar? Our radar tower is right in the city of Fort Myers. I forgot to update the NBC2 thing, but the radar tower that we have that you see on TV is at the station in downtown Fort Myers. It's in the parking lot. That's the closest radar tower to the city of Naples. So watch whatever TV channel you want, by all means, but when the weather really is getting kind of crazy, it is best to touch base with Gulf Coast News and just see what the radar is saying. Or if you don't want to watch TV, pop on the Gulf Coast News app, because the radar energy that you're seeing from our radar is the one that's physically closest to you and gives the best idea as to what's actually happening in the Naples area. So again, watch whatever channel you'd like, but when you want to watch when the weather's bad, Gulf Coast News is going to have the radar that's actually closest to you, gives you the best idea as to what's happening with that specific thunderstorm. Last thing I wanted to mention is Michael, the Doppler radar tower. Not only does he send that pulse of energy out, but he also does it in two ways. He sends one beam horizontally and another beam vertically. We talked earlier about cross sections. That means when Michael sends out those beams of energy, he can get a cross section of whatever is in the sky. That's how we can tell if there's small raindrops, big raindrops, giant chunks of hail, a couch, a roof, a tree, whatever happens to be in the atmosphere. We can get an idea as to just how big it is based on the two ways that the Doppler radar sends out those pulses of energy. Okay, last couple of things and then I'll send you underway. Generators. You know, a couple of years ago, the biggest thing that killed people during hurricanes was storm surge. In the last couple of years, that has changed to generators and carbon monoxide poisoning, the disaster after the disaster, and inland flooding. Inland flooding actually killed more people than storm surge over the past couple of hurricane seasons. Think about like Hurricane Helene, the flash flooding that caused in North Carolina. So we've done a great job communicating the risk of storm surge, but now we need to make sure we talk about the risk of inland flooding and generators. Don't have the generator in your house or too close to your house. Especially in your garage. A lot of people are worried it's going to get stolen, so they do it in their garage. If you've got a buddy who has a generator, just remind them. Make sure it's operating outside and away from your house. Insurance. I don't need to tell you how much of a mess insurance is right now, but it is best on a sunny day like today to make sure you know what kind of stuff is covered and what kind of stuff isn't covered. With flood insurance, I asked the National Hurricane Center director one time who should have flood insurance. And he said, take out your driver's license. So I'm like, okay. I took out my driver's license, and he said, what state does it say? I was like, Florida? I was like, then you should have flood insurance. You know, a lot of people based on their mortgage are required to have flood insurance, but there's a lot of people who aren't required to have flood insurance who don't because they think they don't need it. Most of your homeowner's insurance doesn't cover things that are done by water. So even on just a regular stormy day, not even during a hurricane, if water causes the damage to your house, your home insurance is probably going to say, well, we don't cover that, and we told you about it. So make sure you check what you're covered now, and just make sure you have all your bases covered before you actually need to whip out the policy. Evacuations. We talked earlier, you made a good decision living in evacuation zone D because that's one of the last ones that's going to get called. If you do have to evacuate, Chicago and Cleveland are not option number one. Somewhere else within South Florida, we have super easy access to Fort Lauderdale over on Alligator Alley. Lots of hotel rooms over there. So in most cases, what you want to think about is you want to run from the water and hide from the wind. The only time you want to leave your house is during the possibility of storm surge flooding. Remember, your homes, especially in an area like Verona Walk, are built really tough. So you're built for the wind, but there's not much you can do with the risk of water. So if you have folks or neighbors or friends who live near evacuation zones A and B, now's the time to touch base and make some plans to have them come stay at your house should we have another storm that makes a big storm surge event in areas of Collier County. And the last thing is supplies. You know, the gallon of water thing. The recommendation is you have 1 gallon of water per person in your house for at least 3 days. So I live by myself. I've got 3 bottles of water in my laundry room. If I have 3 kids and a wife, maybe someday, that means 15 gallons of water on hand before the hurricane hits. That's why water is the first thing that flies off the shelves anytime there's a storm that even shows any kind of hint of coming near or close to us. So it's better to buy those things like now. You don't have to buy 15 bottles of water now, but maybe 1 or 2 every time you go to the store or something, and just kind of build up your reserve, because that's the first thing that always flies off the shelf whenever there's even the hint of a hurricane coming anywhere close to us. And last thing I wanted to mention is check your sources online. The internet is crazy nowadays, and there's lots of misinformation out there, especially with the weather. If you're going to look on something on the internet, make sure it comes from Collier County Emergency Management, the National Hurricane Center, or one of our local broadcasters. Gulf Coast News is great, but if you want to watch your channels, that's fine too. Be really, really cautious about the national channels because they're not as focused on the local area, and sometimes they hype things up a little bit, I think it's fair to say. And be really careful about accounts that sound real and have these crazy hurricane predictions. Right now, I was scrolling through my Facebook feed yesterday, and there's some account, I forget the name of it, but they have all these cautions and warnings about a new storm popping up next week in the Caribbean, and there's no indications that anything is going to form. People put stuff on the internet because they want you to click on it. It makes them run higher in the algorithm to appear on more Facebook feeds and everything. So if you see something that looks a little scary or something, it's probably from a goofy account. Just keep on scrolling and touch base with the National Hurricane Center, your local fire department, your local police department, Collier Emergency Management, or whatever local news channel you prefer to watch, because you're probably going to get better, more reliable information from those sources as compared to some kid in his basement in Iowa who just wants to post stuff on the internet to scare people. All right, well that's all I had prepared for you then today. You're more than welcome to take off. If you have any questions, feel free to come up here in the front, and thank you for the invitation. And that's